All right, we're on part 2 of the practice test for polynomials. If you can't tell, I've worked all that already, so now we're on to 30. Simplify and write your answer in standard form. So what we're going to do is it's this whole term being added to this whole term. I'm going to erase that so I don't accidentally forget that I'm adding. So here we go. I'm just going to make sure and add the like terms. So those are like terms, negative 6x squared. And let's see, 7x and 11x, that's negative 4x, negative 1 and 1 is 0. And then I'm not going to forget that that guy didn't have any like terms, so I'm going to write him. Now, what did it say? Simplify and write your answer in standard form. And also it does say solve, but if you're a little confused, don't be a little confused. I'm going to go ahead and factor this. Just because I assume that they want me to factor, right? So they all have a 2x in common. So 2x squared minus 3x minus 2. And now let's see if we can factor that. I don't think we can, but 2 times negative 2 is negative 4, and the middle term is negative 3. So actually we can factor this because negative 4 plus 1 is negative 3. So I'm going to slide over here and write that 2x that was way out there. And I'm going to go ahead, I'm going to change this part to red. So 2x squared and that minus 2. And I'm going to go get negative 4x and plus x. So minus 4x plus x. And I'm going to factor by grouping. So that 2x is still out front. And this becomes 2x. So it doesn't become 2x. These both have a 2x in common. So this is now x minus 2. And check it out, that is already x minus 2. So plus x minus 2. If you're not sure why I put the parentheses around it, just to kind of recognize that, hey, this is a group that I'm going to factor out, okay? So I'm actually going to write my answer above this. So we get 2x times 2x. So hang on a second. That seems odd. Oh, okay, I caught myself. I didn't finish factoring the grouping. It's 2x plus 1 that's getting factored, and then the other term is the x minus 2. For a second, I was thinking, wait, should I have factored out 4x squared right here? And the answer is no. But the way that this started to factor made me feel like I should have done that. And no, I did not need to do that. So here is your final answer for 30. If you didn't do that, if you stopped here, I mean, okay, I guess. Technically, you're not horribly wrong. If you stopped here, I really think you probably should have gone here. If you were gonna go from here to here, then I think you should definitely go here. Right, okay. A square picture frame has a 2-inch frame around it. So a square picture frame has I think this should say a square picture has a 2-inch frame around it. So this is what I'm going to do. I'm going to do it like this. The yellow is the picture. Let's put it, there's the awesome picture, right? Okay. If the area of the frame alone is 72 inches squared, what is the area of the picture? So we obviously don't know what the area of the picture is, but we do know that this piece right here is 2, and this piece is 2, okay? So we're just going to call this x. Well, so if this is 2 and this is 2, then this is x plus 4. So if you're like, I'm a little confused. So here's the area of the little picture. The little picture is x squared. That's the area of this is the picture. The area of the frame, so I'm just going to call it AF. That's funny. Is x plus 4 squared. And if you're like, wait, how is that? Well, this is a square picture, so this is all sides are congruent, all those angles are 90, that kind of thing. So if that's x, then that's x, then that's x, then that's x, right? And so not only is it 2 in this direction and this direction, it's 2 in this direction and this direction. So that means that this side is also x plus 4. So what are we supposed to do? Well, it says if the area of the frame is 72, the area of the frame is 72, what's the area of the picture? Well, how we're going to do that is we're going to focus on doing this. So what I mean is I'm going to take that x plus 4 squared and it equals 72, right? So what I'm going to do is expand this. I'm going to distribute, or actually I'm going to do the a squared plus 2ab plus b squared. So it's going to look like this. X squared plus 8x plus 16 is really 72, right? And what we're going to do with this is this will allow us to find x, and then we'll just plug it in right here, okay? So if you're a little concerned about how we're going to do this, we just had to use what we knew. That might seem like not a very helpful thing to say, but anyway, I'm going to subtract 72 from both sides. Why? Because we need it to equal 0. X squared plus 8x minus, what was that, 56? Hang on, let me do a little math here. Yeah, 56. And that equals 0. So can we factor that? Well, the factors of negative 56 to give us positive 8. Let's see. You can, here, I'm just going to start listing factors. So the factors of 56 are obviously 1 and 56, 2 and 28. Can't do 3. Can you do 4? I think you can. It's 4, and that one actually might be it. 4, and I can't, for some reason, 4 and 16. Yep, there we go. So it's going to be positive 16 and negative 4, okay? So we get x squared minus 4x plus 16x minus 56, that is 0. We're going to take out the x here to get x minus 4. We are going to take out 16 to give us x minus 4. And I don't have room for the equal 0, but there it is anyway. And then this factors to x plus 16 times x minus 4. That equals 0. And now solving each of these, this piece is negative 16 and this piece is 4. So x is equal to 4. So let's slide over here, and if we plug that in here, 4 squared equals 16. So if you had a picture frame that was that was 4 inches in every direction, then you would have, it seems kind of wild that the area would just be 16 and that the big purple one would be 72. But if you think about it, like this being 2 and this being 2, these together are the exact same size as this. So anyway, area is an interesting concept because it doesn't quite just, when you double things, it doesn't necessarily double the area. So anyway, yeah, that was a fun one. There, your final answer was 16. All right, the length of a rectangle is 4 units more than its width. Okay, let's draw a rectangle. My number one advice when it comes to basically life, maybe not life, is draw a picture when you're trying to work problems. Visualize, label, do something to give your brain some room to work, okay? So the length of a rectangle is 4 units more than its width. So let's just call that the width. I don't really care. Whichever one you want to call the width, call it the width, right? Because if you draw a rectangle like this and you call this the width, okay, that makes a little less sense, but I'm not going to argue with you. You know what I'm saying? So here we go. The area of the rectangle is 45. What's the length and the width? This is an easy problem because the area of a rectangle is the length times the width. And we are told that the area is 45. So just like this problem up here, we're going to simplify and solve. So w times w is w squared. W times 4 is 4w. I'm going to go ahead and subtract 45 because I need that side to be 0. Can we factor this? Well, let's find out. 45, negative 45, can that equal 4? Let's see. There is 3 and 15. I just skipped 1 and 45 because why? 5 and 9, looks like that's it. Plus 9 minus 5. So this can pretty much automatically factor to W minus 5, and W plus 9 equals 0. And I'm not even going to worry about that one because it would give me negative 9, and we can't have a width of negative 9. This one is a width of 5. So the width of our rectangle is 5, and the length is 9. And if you're wondering, does that work out? Well, 9 times 5 is 45. Next, the sum of two positive integers like that is 25. The difference between their squares, is 275. Find the two integers. Well, what we can do is we can factor this to be x plus y, x minus y, and that's 275. And then hold up, x plus y is 25, so this is 25. So 25 times x minus y equals 275. Well, I can divide both sides by 25 and get x minus y equals, let's see, 20, that would be 11, right? Hang on, is that right? 275 divided by 25, 125. Yeah, it's 11. So here's what just happened. X plus y is 25. X minus y is 11. So can we use that information to then solve some more? Yes is the answer. So it's a system of equations, which, I'm sorry, it's been a while since we've done that, but maybe you will somewhat remember it. So you have this equation, and we can combine them by just adding, and we're going to get 2x, and then those cancel, equals 36. So x equals 18. So one number is 18, the other number has to be 7, because that's when you add them, you want 25. So 18 is one number, y is 7, and if you're like, that satisfies the adding one pretty easily. I mean, if you want to double check, 18 squared, I don't know what that is, 18 squared is 324. So 324 minus 49, that is in fact 275. So there we go. The answers are here. Find all the values of k so that each trinomial can be factored using integers. So what we're going to do here is basically a times c would be k, and we want to get 12. So I guess there could be lots of numbers, but the idea is that there could be 1 and 11, right? Because if we add those two, that would be 12. 2 and 10, 3 and, why can't I think? 3 and 9, 4 and 8 and 5 and 7 and 6 and 6. So all the values of k would have to be, let's see, 1 times 11 is 11, 2 times 10 is 20, 3 times 9 is 27, 4 times 8 is 32, 7 times 5 is 35, and 6 times 6 is 36. Those are all of the values of k, so that this could be factored with integers. Are there negative versions? Nope, we don't got to worry about that because we want k to be positive. So we're done with that one. So doing the same thing with this one, this is 20 and this is k. So essentially this one, here are the factors of 20. There's 1 and 20, 2, 10, 4, 5. I mean, that's it. So if we had those, k would either be 21, 12, or 9, because that would give 20, that would give 20, that would give 20, and when you combine them, we would get that. And again, we want k to be factorable using integers. So hold up. This one doesn't say that k has to be greater than 0, but I guess that doesn't actually matter in this scenario. That's just it. Find the values of k that make that thing a perfect square trinomial. Okay, so this looks like a squared plus 2ab plus b squared. So b squared must be k, essentially. So a is 3x. And then, so here, let's do the plus 2. This is 3x. There's our b plus b squared. So this thing equals 30x. So 6xb equals 30x. Divide both sides by 6x, and you get that b equals 5. So k is 25. So when it says find the value of k, it's 25. Find an expression for the area of the shaded region. Well, that should remind you of this one a little bit. Also, depending on what happened after I recorded this video, you might be looking at this going, that looks like some crazy sauce happened here. It might have. It might have. So anyway, find an expression for the area of the shaded region. Well, so the area of the, hang on, we have to use blue for that because it's blue. The area of the blue is equal to x plus 5 squared. The area of the white, I'm just going to write it in yellow, is x plus 2 times x plus 3. And all we're going to do is just subtract these, okay? So I'm just going to scooch over here and write this out. This one is x squared plus 10x plus 25. I know that because it fits that. And this one right here is x squared plus 5x plus 6. I know that because I foiled it. I distributed it in my head. X times x is x squared. X and 2 is 3x. I'm sorry, x and 3 is 3x. 2 and x is 2. 2 plus 3 is 5. And 2 and 3 is 6. So now, like I said, we will just subtract. That's gone. 5x plus 19. And that's the expression. Thought that one was going to be like trickier, but no. Okay, so you might have noticed if you got this far in the video that I didn't answer this one. And that's not true, actually. I spent a lot of time answering that one, but went too far with it, okay? So let's go the right amount of far with it. And what's going to happen is the area of the square below is this. Let's write that down. 9x squared minus 30x plus 25 is that square. And we could do this. The area of that square is really y squared because it's, y times y. And what we're going to do is that equals 9x squared minus 30x plus 25. Well, check this out. That's a perfect square. That's a perfect square. So what we can do is quickly factor this to be 3x minus 5 squared, and that equals y squared. We can solve that y by taking the square root of both sides because that's squared and that's squared, and we get pretty simply that y equals 3x minus 5. So that's the first answer. And if you're like, you overthought it, Mr. McMath, what did you do? I did that. So that wasn't the overthinking part. The overthinking part came a little bit later. But what we're going to do next is take this. If y equals this, I'm going to plug that in here. I'm going to plug that in here. So we'll make this one blue so that, me and color coding. 3x minus 5 plus 3. Where am I getting the plus 3 from? Right there. So that's 3x minus 2. And then we'll make this one green. So y plus 2 is 3x minus 5 plus 2. Where did I get the plus 2 from? Right there. And then this becomes 3x minus 3. So the area of, I'm going to call this the red one because now it's red all of a sudden, is this, but we're going to go ahead and distribute it so that it looks like this. And the idea is we get 9x squared. Let's see, I guess I'll go ahead and distribute this the long way. So 9x squared minus 9x minus 6x plus 6 is 9x squared minus 15x plus 6. So if you're wondering when did the overthinking begin, it's after I got that. I tried to solve for what y was, for what x really was, and yada yada yada. It was fun and took like an extra 10 minutes of time. So this is answer number 2. That's it. So we have officially done the entire practice test. Let me know what questions you have. See you later.